Hello, welcome to another Blender Sushi live noding using animation nodes. Um, Today we will be covering something that's slightly simpler. Basically, our favorite topic will be animations because animation nodes is really should be focusing on animation. Sometimes we get to area that's a little bit complex. You definitely need to understand some of more complex area like math or perhaps some little bit of programming, because animation nodes itself is kind of like a visual programming. But I will show you really quick that even with such a simple knowledge, you can create some interesting procedural animations. And our big topic is tracing. We're gonna try to kind of trace animation. Let's say we have like an object like that in the scene, and then you make it animating, and you wanted to trace the path of the animations. This is actually like a super basic knowledge, but many animators still find it so difficult. Like even in a big 3D animation package, other big one, I won't mention a name, but even to trace animation, you need to have like a script, and then the script is only doing it for one time. It doesn't update, etc., etc. But let's try how we can do that using animation nodes. Start from the real basic one. We're just gonna trace the motion of animations, just like object animations. Later on, I might cover things like tracing the vertices, or perhaps tracing particles. Whenever I'm showing like a feature in that you can do using animation nodes, I always try to do it using Blender own built-in feature, so you can compare the two. Alright, so we have Blender already open, and I'll hide the lamp and the camera. This cube object, I will just use icosphere because icosphere is like kind of rounded. It's easier for eyes to see. Okay, we have our objects, and then if someone told you, okay, I want these objects to start moving procedurally, you can actually animate this and keyframe it, but I will just use animation nodes for that. I'll go to compositing area here and create a new node tree. So I have this icosphere, and I will animate it, and I will just use the wiggle vector for the position of this object. Yeah, the locations. Blender call it location. Sometimes it's called position or translations, XYZ. And so let's create a frame. Frame node will drive the evolutions. But first of all, we need an object transform output node. Let's grab this object, and with the locations here, we will push it using the vector wiggle. I will make it really clear, so I will use the debug drawer right here, and we're gonna plug in the output here. So as you already know and familiar with the wiggle node, if you move the evolutions using time, the value will change, kind of like a noise kind of value, and it's kind of the object will travel through those value. Don't get mixed up with the seed. The seed will make your objects kind of jump around like this. Sometimes you want it as well, but in our case, we will use the evolution. You can control the speed, etc. and whatnot, make it fast and slow like randomly. Maybe that can be interesting to do. For now, we keep it simple and just make our object traveling like that. We can increase the speed like 2. Amplitude, we're gonna leave it like that. Let's save this object. Save as motion tracing, object tracing. So Blender actually has its own like a trace kind of related features. They call it motion path. I believe it's it's only calculating when you actually have keyframes animation. Since we are doing it like procedurally, of course you can have like a live tracing using animation nodes, but for now let's just simplify things to the very basics, kind of turning this into a keyframe animations. So keyframe, there is a node called set keyframe, and this will allow you to keyframe the objects in the scenes. So we just enable it, and then what do you like? Location, rotation, scale being keyframe, or scale, just rotation, or location, or custom. We're just gonna use the location for now, and then click on the plus button. Now the locations will be keyframed. You could actually just keyframe just the location X, Y, and Z, so it's a 3 value. But if it's a -1, if it's 0, it means only the X will be keyframed, 1 for the Y, and 2 for the Z axis. If you want all 3, it's -1. And then you just need to run the animation once, and it will trace, it will keyframe the animation. Let's just wait for 250 frames. This is probably slower because of the motion path here. It's actually really fast. Stop it now. So there's this motion path. I think we can update the path. So there's a path. We can get rid of it like that. Frame animation. So we have our animations. We can now, I'll just get rid of the animation nodes. So we have this guy, and we can calculate the motion path. We can then hide the number. So this is Blender built-in features. Really handy to see where the object's traveling. The blue lines is where it's going to, and the black line is like the path it went through. You could actually set it so it's just displaying the path, the before and the after. Let's say after we just zero it out, and we have just the trace path before the object, like that, kind of a little bit like a snake kind of object. I'll scale down our objects. So that's a motion path. You cannot render this out. There's probably like a script that can bake the path, but that's a Blender built-in features. I just want to show you. You can increase the step and turn on the frame number. Really useful for animators. Normally they want to see the track of their controller or object, or actually the track of the animated object is more important than the controller, but you can, by seeing the motion path of animation of the controller, you can kind of tell if there is like a bump or something. Okay, let's just get rid of the path. Let's see. Okay, back to animation nodes. So we have our objects animating frame by frame, and now let's kind of create what I'm trying to show you. It's kind of I'll make a duplicate of the objects every time the frame gets updated. So at this location, that object is there. I want to create a duplicate. So it's kind of tracing the objects over time. Okay, I'll just show it to you. We're gonna need an object instancer, and then of course gonna create a loop. Before I do that, so we're gonna generate instances every time, every frame. So plug it to that, and we will do it. We will using our animated object as the master. Next is interesting. That seems to be calculating. Somewhat is slowing down Blender. Also, I'll just create a new scene real quick, and let's quickly do that again. Object transform. Maybe I have something open up. With the wiggle speed, put it to 1, amplitude maybe 6 frame. Frame's gonna push the evolution, and we will keyframe this object, enable location, and then keyframe it, and just kind of we are breaking the animations once again. Maybe Dropbox is slowing down my MacBook Pro, but it's okay. I will be showing you twice. Okay, it's done. Well, save as number 4. We have our objects traveling. Can make it smaller. And now let's create object instance there. We're gonna create a duplicates on every frame. Let's grab our object, and we will kind of loop it. And I'll name this is our object instance. Copy. Next thing I will do, I will actually source the object itself. So the one that's animating, that's the master object. Object input. Grab our object, animated object, and then we create a new parameter. It's just our object. It's plug that in. And we know that normally we use the object transform output. That's gonna be for our instances. And with our source object, just the object master or the source, I will use something called object transform input. Let's plug that in. If I do that right now, so the instance copy will follow the master exactly, like all instances will follow the master. I will now, there's like a hidden feature here, like I mentioned at some point under advanced node settings, you have this use current transform and then frame type offset or absolute. So if I turn it off, now what happened is you can actually source the object's position at different times in frame at different frame in time. So let's say, okay, we're gonna offset, we're just gonna leave it as offset for now, perhaps 5 frames offset. So what happened is our instances is 5 frames ahead of our master. If we say -5, it's gonna be 5 frames behind, but all of the copies are in the same place. But what's interesting is if you plug in the index into the frame, because the index goes from 0 to the number of instances, so you kind of can stagger, you can offset each and every instance copy slightly off in a time frame. Let's just try and have a look. Now you can see we all start to see the kind of like a trace, like a look like a snake. Let's turn off this relationship lines first. We select the object instancer. It's in this menu here, hide relationship lines, or you can just use the hotkey U and then hide the relationship lines. Okay, and let's save this real quick. File, save as new version. So what happened? Start from frame 1, you have like frame 1 you have only 1 copy, and frame 2 2 copy, 3, 4, 5, 6, 7, 8, 9, 10, and each of them is gonna be generated in real time. Actually, even this probably so I shouldn't jump frame here because it might not be updating properly. So if you just leave it like that from frame 1 to frame 250, you should be seeing 250 objects. Maybe there is a limit, but I don't know it yet. Supposedly let's say we have only like 10 instances. Let's see what happened. So our instance object is moving. So I should be selecting the master. So I'm selecting the master object, and it's actually behind. You might want it to be kind of, the copy shouldn't be in the front of the master, so we want the master at the front. So we offset it using math. So just plug it in. Maybe offset it like 10 because we have 10 10 objects. So yes, that's kind of what I want. So the master is at the front and then the instance copy is behind. That's how you can use the advanced features of object transform input. In the way you have like, you kind of have like a different time for each object. This you can also use like a multiplier. Let's say every 3 frames or every 5 frames behind. So it's really cool effects, and the offset here can be based on the number of instances we have. If we use absolute, let's have a look. Object transform input, and then if we have like, if we use the absolute, you can see the difference. Let's say turn off the multiplier, absolute. Seems like it's not doing anything. Let's see if we plug in the index. So it's an absolute, apparently, so it's an absolute number, so it's not updating the animations. It's just displaying the number of value at that point. So that's kind of, that makes sense. So you can really control the trace. You can grab the value of this guy's position at any frame. Hope that's a little kind of clear. Yes. We probably like the offset better for animators, so it's like okay, make it -10, so it's following behind this object like that. Of course, at this point you can kind of play around more with the instance, especially let's say the scale. You can make the scale to go down for each copy. So of course you can make it smaller or bigger, but if we use the index and multiply it by, whoops, see. Not a vector multiply, we're just gonna need a math. For every value, we're gonna multiply 0.1. Is that a vector math? That's really weird. Vector from value. Oh, so that's because of this. So index multiply 0.1, pipe that into the scale. So you have that kind of effect, kind of like a moving spirit or ghost. If you render this out using like a Blender freestyle, it's gonna nicely render the outline. You can use like a meta ball as well to get a interesting effect. File save as. Maybe we should try that. Meta balls. So our trace is gonna be the meta ball objects. It might not be working. Interesting. Probably I missed something, or maybe I need to use deep copy, or Alright, that's the effect I want. The multiplier can go. This is that thing. Make it smaller. Yeah, like a moving spirit ghost. You can hide the master. This is the master also. Okay, apparently we need the original master to show up. So that's how you could use the advanced feature of object transform input to generate like a object trace. Do play around with the idea of how you can control multiple array of objects at different time. It's really powerful because you can control also the rotations, for example, and create kind of like a maybe like a weird DNA pattern. Maybe I should try it real quick. So if I use the cube as copy, the cube copy, I'll make it smaller and then scale it in maybe X direction. Scale it in X and then update it. Let's update U. So we have that kind of effect, but the directions you need to, you can use the vector. I think we did it before. Probably the rotation of the object. We use the location as the rotations. I think that might do the job. Let's have a look. Oh yeah. Okay, yeah, that's actually working. So in fact, if you doing like a Euler rotation math, Euler math, you could probably have more interesting result, like kind of rotating the object, stagger and rotate each object's slightly different for each rotation. So you can just index once again and use degree and use the multiplier. Let's hide this guy. Here, okay, we have that guy. Let's hide this master object. Maybe we can have like more instances, like 20. So that's interesting. Is it in the X or is it in the Y? Interpretations. Probably I shouldn't put the Euler mark over there. Maybe it should be somewhere before. Anyhow, do play around with this and see what you can come up with. Get used to the idea how you can kind of offset by using the index, whether it is a location, rotation, or scale. And then now, since you have something like a new knowledge about this offset and absolute, you can take advantage of that. I also want to point out there's a YouTube channel. It's a by this guy OG. I don't know his real name, but OG channel has some quite advanced examples on a tracing, on the subject of tracing. So do have a look at his YouTube channel. Hopefully, yeah, this example is pretty clear. I'm doing it really slowly, and I'm just gonna do. I just did it today. I just use the super simple tracing concept. So see if you can do it to multiple objects, or see if you can do like a line tracing using just animation nodes. That will be covered on the next video. So thank